All right, welcome to The Explainer. Today, we're going to peel back the layers on a technology you use every single day, email. And we're going to see how something that seems so simple, just reading an email, can actually trigger silent, cascading failures across your most important systems. It all comes down to a hidden threat in something called MIME parsing. So picture this. A critical automation just stops working. A support ticket completely vanishes. A crucial alert never shows up. So you're scrambling, you're checking the code, combing through the logs, and your business logic seems totally fine. So what's the deal? What's the ghost in the machine here? Well, it turns out the problem isn't very deep inside your application. Nope, it's right at the front door, the exact moment your system gets an email. This failure happens at what's called the ingestion boundary, before your beautifully written business logic even gets a chance to run. You know, we all tend to think of email as just text. Simple, right? Easy for a machine to understand. But as we're about to see, that is a really dangerous illusion. What seems manageable in a nice, clean test environment quickly turns into an absolute minefield with real-world, messy emails. I mean, just think about it. You open up your mail client, and what do you see? A single, coherent message. It's got some text, maybe a picture, an attachment. It looks simple, clean, and totally straightforward. But here's what the machine actually sees. As you can see here, that one email is really a complex, structured MIME tree. You could think of it like a set of Legos. There's a main container block, then separate blocks for the text version, the HTML version, images, and attachments. It's not one thing, it's a collection of nested pieces that have to be put together just right. And it gets even crazier. Before you can even get to the content, you hit another layer of complexity. The text might be encoded in something like base 64. File names for attachments could be split across several lines and have to be carefully stitched back together. And get this, an email can even have another full email buried inside of it. Okay, so let's say you've managed to navigate the complex structure of the email body. You think you're in the clear, right? Home free? Wrong. Not even close. The email headers, the very metadata you rely on for routing and everything else, have their own nasty set of challenges. The author of our source material just hits the nail on the head with this quote. Raw email headers are not the clean, simple key-value pairs you'd hope for. They are messy, they are complex, and you absolutely cannot trust them for automation until they've been properly cleaned up. And this slide just says it all, doesn't it? Look at that raw header on the left. To a simple piece of code, that's just gibberish. It's folded, it's encoded, it's totally unreadable. It's only after a complex normalization process that you get that clean, human-readable version on the right, which is what your application actually needs to work with. And getting from that raw mess to the clean version, it is not a simple find and replace. You have to unfold headers that are broken across multiple lines. You have to decode special character sets. You have to handle international text. And all of this has to be done perfectly and consistently every single time. Okay, so this is where things get really dangerous. If you have multiple services parsing emails and they make even slightly different choices, like how to handle a weird space or a specific encoding, you get chaos. System A routes an email just fine, but System B, reading the exact same message, misses it completely. This creates silent, maddeningly difficult to trace failures. So we've seen the chaos in the headers, but the problems don't stop there. You've navigated the structure, you've normalized the headers, and now you're at the message body. But as we'll see, what the real body isn't as obvious as you might think. A lot of emails are sent with something called multipart/alternative. It's just a fancy way of saying that the email contains multiple versions of the same content, usually a plain text version and an HTML version. This forces your system to make a choice. Which one do you treat as the real body? And that choice has major consequences. You might think, oh, plain text is safer, let's just use that. But you could be throwing away critical information. The HTML version might have essential links or tables or some structure that a downstream workflow is totally dependent on. Make the wrong choice, and you've just silently broken something else. All of these problems, the complex tree, the messy headers, the ambiguous body, they all point back to one single fundamental mistake. We've been treating email as if it's a simple string of text when we should be treating it as what it actually is, complex, structured data that demands a much more robust process. So what's the solution? Well, the source argues for a major shift in how we think about this. We need to stop seeing email parsing as some small utility function scattered around our code. Instead, we should treat it as a dedicated boundary service, a critical layer that acts like a border guard for our entire system, whose job is to turn messy, raw email into structured, trustworthy data. This big shift means creating one centralized, authoritative normalization layer for your whole system. As this slide shows, this one layer performs a fixed set of operations in a specific order. It parses the structure, it normalizes the headers, it selects the right body based on a clear policy, and then, and this is the most important part, it emits a single, stable, standardized data model of that email. This becomes the one version of the truth that every other system can trust without question. And that's the ultimate goal here. One, and only one, source of truth for what an email contains. By centralizing all that parsing logic, you eliminate the ambiguity and inconsistency that causes all those silent cross-system bugs. No more guessing, no more divergence, just one answer. And why does this matter so much? Because of something the source calls the blast radius. A tiny mistake in a single parser doesn't stay a tiny mistake. Your downstream systems, the ones handling routing, search, automation, compliance, they all treat that parsed data as absolute gospel. A small error at the front door becomes a catastrophic business failure down the line. And the source concludes with this powerful thought that really sums it all up. The moment your system converts a raw email into structured data, that is the critical moment. That's the point where reliability for all your email workflows is either firmly established or quietly and permanently lost. And that leaves us with a final, really important question that goes far beyond just email. It forces us to look at our own systems and ask, where else are we treating a deceptively simple input like a string when it's really a complex structure? And where else might a hidden parsing problem be the silent killer of our system's reliability? The answer might just surprise you.